Hello. Um, am I audible? Good evening, fellows. Hello. Um, okay, fine. So let's continue from where we left yesterday. So we finished loops, right? Um, we finished loops. We finished iterations as a for whole. As a whole. If we saw what are for loops, what are while loops, how we can control the flow of the statement, and what are infinite loops. And we also had an assignment. I hope you did it and found it interesting. We'll quickly go through the solution of the assignment and then proceed with the remaining session. Um, so I'll just open the collab file. So this was our assignment, right? I hope you're able to see it. This was our assignment of yesterday, and before we actually discuss anything, let me also remind you to mark your attendance uh, in the link. I think the link has been shared. You have to mark your attendance for all 5 days of the boot camp to be able to eligible to be eligible for being able to be eligible for the certificate. Please mark your attendance. Right. I think the link has already been shared. Please open the link. Right. And yeah, please open the link and fill it. And there's also a free internship as campus ambassador program by Corizo. Um, yeah, it has the various perks associated with it. If you want to be a part of my Corizo, um, please do, and I mean, if you feel interested, want to be a part of Corizo, please do also, apply for this, right? So do remember to mark your attendance, right? The link has already been shared. Please mark your attendance. Now let's continue with the session. First, we solved yesterday's assignment, right? So yesterday's assignment was to implement uh, the sine function using for simple loops, and we had said we use either for and while loop. The input was supposed to be you know given by the user. So you are supposed to take off decimal input from the user and then return the sign of the input. Now first thing first, this so we gave a hint as well, right? He used the Taylor series. Now this is the Taylor series. This is an infinite series. That means the series goes for infinite terms. For sake of practicality, we said ki if you just take 10 terms out of this and add it and give it to us, it's fine. You can also go for more terms if you want more precision, but nevertheless 10 should be enough. Um, so we have to take an input from user and convert it into, give the output should be the sign of the input. Now this Taylor series is valid only for radians, right? So I hope everyone is familiar with the concept of degrees and radians, right? Um, this is valid only when x is in radians. So the let's first write a code where we take x in radians only, right? So enter x. We put a small note here for our user that please input in radians, like so. For we ask our user to input in radians, and then how we proceed with the code. Now, this is the code which I have written. You might have written a different solution that might be even shorter than this as well. Just for sake of explanation, I found this. I mean, this is slightly lengthy solution, but then this should be able to do the needful, right? So we start by defining a variable called sine. We assign it 0. We define one more variable prod, and fact we assign both of them as 1. We define a final variable as flag. Okay. And for solving this, we use the for loop. Right. I hope you're able to see the screen as well. Um, so we use the for loop for solving this problem. So for I in range 1 to 10, 1 to 20. So I is a variable here. Okay. For loop requires a variable. We all know this. I is the variable, and I is taking the value, all the values from 1, 2, 3, 4, 5, and it goes till 20. Okay. Now I wrote something here. Okay. Hashtag and then some text. Now this is called a comment, right? This is called a comment in Python. This is called a comment. This is completely ignored by the Python interpreter. I mean the thing which runs your program. This is completely ignored by it, and you can just write a comment anywhere in your code. It will be completely ignored. I'm sorry for the noise. Um, it will be completely ignored by the the thing which is running the code, and you write it just to explain your code, right? So here I takes the values um, starting from 1 2 3 till 20. Okay. And as I takes all these values, this code blocks keeps executing for every value of I. Okay. So first I takes 1, prod star equals to x. Okay. Now what does star equals to mean? Star equals to mean that um, prod is equals to prod star x, right? So in a single iteration, I mean in every iteration is a step in the loop. In every step in the loop, we multiply x to prod, right? Here, the next thing we do is we multiply I to fact. Okay. So fact equals to fact times I. We multiply I to fact. Then if I is even, we print print the value of prod, fact, and flag. So flag is this variable, and if I is even, we add something to the sign variable, and we assign. Now this is what this is. We multiply flag with -1. Basically, convert. We change its sign, right? So in every iteration, what we do, we by default multiply x to the prod. We by default multiply I to the fact, and yep, we by default multiply I to fact. And if I, okay, if the looping variable is even, I'm sorry, not even, if it is odd, then we print it, and we add this expression to sign, and we convert the sign of the flag. Okay, we convert the sign of the flag. So initially flag is +1, because after this code block executes, flag would be -1. Flag becomes -1. Okay. So what happens? So what actually happens is in every iteration, the prod is taking a new higher and higher power of x. Okay. Initially it was like power 0. After one iteration, it became power 1. And also in every iteration, this fact is actually taking a higher and higher value by getting multiplied by higher value. So if you like think from if you like put some thinking to it, what we are actually doing in every iteration is we are calculating factorial of I, right? So by multiplying I to this fact, we are calculating factorial. So when I takes value 1, this fact stores factorial of 1. What is factorial? Factorial of 3 is 3 times 2 times 1. Factorial of 5 is 5 times 4 times 2 times 2 times 1. Right. So factorial. In the when I is equals to 1, we have fact as factorial of 1. When I is equals to 2, we have fact as 2 times factorial of 1, which is 2 times 1, or factorial of 2. When I is 3, fact is 3 times factorial of 2, which is 3 times 2 times 1. Right. So at every step, this fact is nothing, storing nothing but the factorial of I. And this prod is storing nothing but the power of x. If we have encounter a odd index, I mean an odd value of the looping variable, like in all the odd variables, like so when I is 1, prod is storing x to the power 1, and fact is storing 1 factorial. When I is 2, prod is storing x to the power 2, and I mean fact is storing factorial of 2. When prod is 3, I is the when pro I'm sorry for the um, mispron- mispronunciation. So when I is 1, prod is storing x to the power 1, and fact is storing 1 factorial. When I is 2, prod is storing x square, and fact is storing 2 factorial. When prod is 3, when I is 3, prod is storing x to the power 3, and fact is storing 3 factorial. And when I is 4, prod is storing x to the power 4, and fact is storing 4 factorial. Right. So in every step, we are actually storing a higher power of x and a higher factorial in fact. Uh, Higher factorial in fact, right? So when we encounter odd in odd value of looping variables, right? When odd value of looping variable matlab x की power some odd number and factorial some odd number, we add it to the sign multiplying by the flag, ठीक है? And then we change the sign of flag. So initially जब like x to the power 1 we are divided by 1 factorial, उसके उसको हमने ऐड किया साइन से, एंड देन हमने क्या किया कि वो फ्लैग वेरिएबल को चेंज कर दिया, ठीक है? ये फ्लैग वेरिएबल को -1 कर दिया। तो अगली बार जब ऐड होगा, ठीक है, तो ये तो पता लग गया कि ऑड में ही ऐड हो रहा है, ठीक है? only when x की power only when looping variable takes some odd value, then only it gets added to the sign, to this sign variable, ठीक है? So हर बार जब ये ऐड हो रहा है, हम क्या कर रहे हैं कि ये फ्लैग का जो वैल्यू है उसको नेगेटिव कर, नेगेटिव है तो पॉजिटिव, पॉजिटिव है तो नेगेटिव कर रहे हैं. So in this way, what we are actually doing is, if I try to print this, first we have zero point 0.5, fact is 1 factorial. So x to the power zero point 0.5 to the power 1, 1 factorial, and flag value is 1. In the next time when we add, okay, we have zero point 0.5 to the power 3 and the factorial of 3, and flag is -1. The next time when we add, we have zero point 0.5 to the zero point 0.5 to the power 5, and this is 5 factorial, and flag is 1. So in this way, we actually like, you know, find this sum. We are actually um, seeing this sum, and we are storing it in sign. So now we can like safely, we just have to print sign, uh, sorry for the typo, sign. And this should, let's also make this a little user friendly, is, so I input 0.5 as x, and my sign of x is 0.4794. You can check this in any calculator. Let's check it in some calculator. We've Okay, we have the scientific calculator. Where is trigonometric sine? Okay, this doesn't have. Yeah. Let's find some better calculator. Sine of, okay, it's 0.5, and what should it return? And it is returning the same value, 0.479. Okay, which is what we found out. Right. So this is how you can actually, this is a little tricky, I know, but this is how you can find the the value of sine function. So we did spend some time with it, but then I thought like this is very essential when you're studying loops. You should be able to understand loops and see how you can like smartly use them to solve very difficult problems. One way you can actually reduce this is you can get rid of this fact. Okay. When you're already doing a multiplication operation here, why do you have to do two multiplication operations? Let's just get rid of this fact thing, and let's just multiply x by I, right? So now again, think a bit about this key. Will it still work? Let's just see. Let's enter the same value, and it still works, right? Think now I would ask you to like think a bit like why is it working still. Okay, now we will proceed with the remaining part of the session. So we completed iteration. We'll now proceed to the next topic, which is called functions, right? So we remembered that large expressions, right? Large expressions, we stored them in a variable. A large piece of code, we store it in a function. So function is basically an identifier for a code block, right? So a whole piece of code, this function name actually represents this whole piece of code. Okay, this variable name represents this whole piece of expression. Okay. Now just think of it like, okay, I store an entire code block in I mean, I make an identifier identify an entire code block. What if the code requires some input? And what if the code has some output, right? Let us say, okay, I have a code block. Its output I can simply print. Okay, that I can do. But what if I want to store its output in some variable? Okay, what will I do then? So these problems start thinking in this direction, and you will, you might yourself make your own language or very easily learn how Python, very quickly learn Python, because these problems only the computer scientists thought of, and accordingly they designed, I mean made this functionality in Python. So function is again a programmer assigned name which serves as identifier and identifies with a whole code block. It generally used to shorten the length of code where a particular code block is repeatedly used. Okay, so again it reduces drudgery. We encapsulated a code block inside a function. Now let's see how you define a function. We use the def keyword. Okay, this def and is called a keyword. Okay, this is a Python reserved word, and you shouldn't use this to define variable names. I mean, you can use def1, but don't use def. Uh, function name. What function name you can have? Any variable name can also be a function name. So function name follows the same rules as variable names. There are some arguments. So after that, you have to have these parentheses, and inside it there is like space for some arguments. Okay. Now arguments is what the code block requires an input. Okay. It is perfectly fine if the code does not require any input. You can leave this blank. Uh, okay. Yeah. So if it's perfectly fine if the code block does not require any input, you can leave this completely blank. It is still, the code would still work. And please note there is this dot dot, right? This is there, which tells the Python interpreter that there would be an indented code block after this. So indented code block, what does it mean? So the code which you write, you actually indent it and put, put it inside. Not putting it inside a function, you just leave it leave it there. So whatever code you have, you just indent it, and Python thinks that okay, this in code is now part of this function. Okay, there has to be this dot dot, and there has to be this indentation. Okay. Now this is an example of how you can define a function. You have the def keyword, you have the function name, you have an argument here, and this parentheses and colon, and we define these variables. We define some variables. We define have an entire code. Now we know that so this code is basically calculating factorial. Okay. What we are doing is we are iterating from 1 to n plus 1. Why? Because range does not ignores the last. Okay. It will iterate only from 1 to n. Okay, so we are iterating from 1 to n. This variable I is taking values from 1 to n. Okay, n plus 1 is ignored by range. And for each value of I, we smartly multiply it with product. With the prod variable. And finally, we return prod. Okay, we return prod. So what I said is कि okay, let us say my code block had some output. Okay. Now I can simply display that output by using the print function. But then let us say I want to store that output in some variable. So we cannot like Python does not give us that much independence to store this prod in some random variable which can be used beyond the scope of this factorial, beyond the scope of this function, right? It does not like provide any flexible method for that. So instead what it provides it is this return keyword. Return keyword is basically, as the name suggests, returns this value. Okay, returns this value. So return keyword returns this value. Now what exactly it means, more details will come in the next slides. Okay. So again, this is explanation which we just went through. Some details which I would like to cover here is the concept of local variable. Right? This variable defined inside product, inside this function is called a local variable. This prod is called a local variable, and it cannot be accessed outside the function. Right? So like if you have some code outside the function, which is not intended, so outside the function, like this is a code outside the function. This code cannot access this variable prod, right? Um, so what we did is we use this return keyword, okay, return and then prod. What this return prod does is key, okay, this function, okay, anywhere you use this function, like here we are using this function. This is called function calling the function. Okay. So how we call a function is we just write its name, parenthesis, and if it has any arguments, we supply those arguments. If it does not have any argument, we leave this place blank. Okay. मतलब कुछ nothing, we just write parentheses open, parentheses close. That's it. But since this is taking an argument, enter we give it some argument, and what Python does is, okay, in backend, it just erases this stuff, and in place of it it just puts the value corresponding to this prod. Okay, so here we called factorial 5. So this prod, okay, at the end of this entire loop should be storing 120. So this function factorial of n is returning 120. So in backend, when the Python executes this code, Python would simply erase this, and in place of it just place 120. Okay. So, I'm saying erase, it's kind of a very crude word. Execution involves replacing factorial 5 by 120. Okay. If it did not return anything, okay, if it did not return anything, then it does not like replace anything. It just leaves, it just removes it. Not removes it. This factorial 5 gets replaced by blank. Okay. Or in technically, it gets replaced by none, something called none. So in Python, I'll quickly show it here. Um, there is something called a none. Okay, none is a keyword which represents nothing. Now, let us say I define a function here, factorial again. Let me define it in a different way. It requires some arguments. Let us say we have n, and again, we just do the code. We just use the code prod equals to 1 for I in range 1 comma n plus 1. We just, and then we just print it, print prod. In this way, we still display our output, but we do not return anything. If we do not return anything, we can just leave it and go to the next line and call it. Uh, Factorial 5, it should return 120. It should show 120. Oops, a small mistake. Here, I should be there, 120. I hope I haven't. Oh, I have made this mistake here as well. I'm sorry for the mistake. I'll quickly correct it. Yeah, please, whatever code I show, I'll definitely give these slides to you. Please ensure that, oops, please ensure that you execute this code. You write this code as well yourself and execute them. Right. Mm, now, where did that go? Yep. Okay, it's there in every slide. But ठीक है, let's just go to this. So it displays something. ठीक है, it displays something. But let us say now let us say I try to print it. ठीक है, let us say I try to print it and see. ठीक है, so it prints none. So since this returns nothing, ठीक है, you can alternatively write return and leave it blank. That will also have the same effect. Since this function returns nothing, Python replaces this in the execution round. Python replaces this by a none, and it is same as this. Okay. Uh, okay. So you get the point, right? Ki what Python does. Python does curious stuff in the backend. So we encapsulate the code inside the function, which means we just use an indentation. So what exactly is an indentation in Python? An indentation is actually a tab. That's it. It might be so different editors actually interpret it differently. Like for some editors, it is 4 spaces, while in Colab, it is just 2 spaces. Okay, a tab means 2 spaces in Colab. Now there is you can use VS Code as well. Okay, it is another ideally, and it has 4 spaces. You can use the Python's default integrated development environment that also has 4 spaces for indentation. While Colab is a little curiously different. It has only 2 spaces. Um, Next is again programmer assigned. Yeah. So here I'm showing how we can call it. Right. So we can store this. So we can since this is returning something, we can actually store this in a variable. If this was not returning anything, Python would just store none inside it. Okay, and when you print a, it will print none. But since here it is storing something, when you print a, it prints 24. Now moving on, we discuss some very important concepts here. I did tell you about the stuff called local variable. So we mostly have like 2 types of variables. One is global variable and one is local variable. Local variable is restricted to the scope of the function, so it can be used only inside the function. Like here, uh, C is a local variable. It can only be used inside the function, while A is a global variable. Right. Since A is defined before the function, it can still be used inside the function. Okay. It can still be used inside the function. But if we do not write this global A statement here, we can only access the value of the function. We can only access the value of A, but we cannot change it. If we intend to change it, we have to write this global A. So when we write this global A, this accesses the global variable A, and it can not only print it, but also it can change it. If we write a global B here and has not been defined yet, so it just defines a new global variable, right? And again, we can change it. It can also be used inside the function. It can also be used outside as well, right? So this is a very interesting piece of code. So what we are doing is we define a equals to 4. We write global a, global b, and we define a local variable. We try to print it outside the function. It will give you an error. You can try this as well, like define any variable inside function and print it outside the function. It should give you an error. Okay, but next is print a, print b. We call the function as well. Like this is a function. This does not return anything. Such functions are called void function. It also does not take anything. So you see that there is nothing here, so it does not take any argument. So when you call this function, this the value of a gets updated because in the function we are adding a 5 to the value of a. So a earlier had 4. So now if we print a, it should print 9. Um, we defined a global variable called b inside the function, and we assigned it a value of 4. When we print it, we should see 4 here. Beyond this, like this is nothing. That only this was the only concept, like local and global variables. Um, this is pretty important. I would say that, uh, like, to understand it, many of the bugs come because people mess up global and local variables. So, right, this only I was saying, yeah, this print C should give you an error. Apart from this, yeah, I wrote a hashtag thing. Okay, I already explained this briefly, that this hashtag gives an error. This hashtag and anything you write after an hashtag is called a comment. Comments are benign pieces of codes in your program. Python completely ignores them, okay, while processing your code. You can have a single line comment. Okay, single line comment starts from a hashtag. Anything written after a hashtag is gone. Like, it is a comment. Um, so please don't write any code in after a hashtag. Apart from this, you have multi-line comments as well. Multi-line comments have to be enclosed in three quotation marks. You can use the double quotation marks. You can also use the single quotation marks, but you have to write three. These multi-line comments are also called doc strings, and in fact, they are actually strings. They are a data type. You can store them in some variable, but we use it to write comments. But anyways, let's move forward. That was a slight digression. Now we move into another interesting concept of recursion. Okay, so we saw how a function can be defined, right? We saw how a function can be defined, and we also saw how we can pass an input to it, how we can retrieve an output from it. Okay, there are multiple ways: display, global variable, return it. Now, again, some in curious personality came, and he or she, I don't know his or her gender, but so the curious personality just asked a question: what if I just call the function inside the function definition? What will the Python do then, right? So def, this is factorial. We defined a factorial. We define something called a base case. Now, this is not important. What's important is we are calling the function inside its definition. So we are calling factorial inside its definition. Now, this type of coding is called recursion. Okay, this is again a very smart way of fooling the Python into getting your job done. So we are calling a function inside a function. Now, think logically what should happen. If when you call a function, the function starts executing this code block, and it calls another function inside it. I mean, it calls the same function again inside it. So again it will go, again it will execute the code, again it will come here, again it will call, and it's sort of an infinite loop kind of thing. Not exactly a loop, but it's like an infinite process. Okay, so it keeps on going. So now you have an alternative for loops. This is called recursion. Okay, so you have an alternative for loop in the form of recursion. And but then some people say, okay, like, it's great that we can recurse, but how we can use it to our to our needs? So again, like, the guy or the girl, whoever it was, who discovered this, said, okay, what if I tinker with the argument? So I passed n in the when I again call it inside, I pass n minus 1. So what happens is, let us say I call factorial 3. Okay, I call factorial 3. This entire code block would execute. If this condition holds false, so it goes to the else, and it returns n times factorial of n minus 1. So this is I called by 3. So it will return 3 times factorial of 2. And in factorial of 2, again, this code block would again get executed. This condition is false, else would run. So factorial of 2 would return 2 times factorial of 1. So I saw factorial of 3 returns 3 times factorial of 2. Factorial of 2 returns 2 times factorial of 1. In factorial of 1, this condition holds true, so it returns 1. So I initially called factorial 3, which returned me 3 times factorial 2, which in turn returns me 3 times 2 times factorial of 1, and which again returns me 3 times 2 times 1, which is basically the factorial. So when you call this, okay, when you okay, I'm sorry for that. Yeah, when you call this basically functions like a loop. Okay, and sequentially it does all the calculation. Okay, Python interpreter does not like return it until all the recursions have been completed. So the final factorial 3 would return me what would return me 3 times okay, see. So the final thing which would be returned to us would be factorial of 3 times 2 times 1, right? So this would be what we get in return um, when we write factorial of 3, right? So this is what we get in return. We can again store this in some variable and do all the sorts of operations we want. We can display it, print it, whatever. This factorial is not restricted to integers and floating points. In fact, there are various factor recursion. Okay, I'm sorry. This idea of recursion is not restricted to integers, although we used it for integers only here. This can be extended to floating point, strings, and all. I mean, in fact, all data types in Python. Okay. So here we saw how recursion. I mean, how you can use the idea of recursion. Now we move forward to the next thing. We get some little more detail over print function. Okay. Sorry for the typo here. It is not capital. It is small p. Right. It is small p. Right. So where you can actually print multiple stuff. Print 1, comma 2, comma 3. You have to like separate them from one, and they get printed with a space in between. Okay. You can print multiple stuff from different data types, and again they get printed. If you want like this separation is of a space, you can actually change it to be a comma. Okay. So here we use this sep keyword. Okay. It's called a keyword argument. So sep equals to comma. So then it prints, the separation is now a comma. Okay. Multiple things are being printed with the separation of comma. Um, by default, if you like have two print functions running one after the other, the output of the next print function would be in a new line. Okay. In a new line, the output would be for the next print function. If you don't want that, you can actually specify a end keyword in your first print, and that would actually like so after this print function gets executed, it won't go to the new line. Instead, it will just print this. So by default value is /n, okay, which is the string value, escape sequence string value for new line. Instead, you can just do this double slash, which is the escape sequence character for backslash, and the next print would be printed after this. Okay. So these are some of the ways you can actually control the way Python displays information to you. Um, we'll now summarize the function. This actually completes our module about functions. We'll quickly summarize what we learned. We learned from how we can define functions, what are function arguments. So we had only one argument, right? Everywhere we had only one argument, we can actually have more than one arguments. Like let us say we have r here, and what we do is we return the factorial plus r. So here we can write 5, so it will return 125, okay, which is 5 factorial 120 plus 5. You can also specify default values, like here I specify r equals to 0. By default r value is 0. So then even if I don't specify this, it will still take the r value as 0. If I specify default value of r as 5, even if I don't specify r, it still takes the value of r as 5 and prints 125. It returns 125. So I can, let me just return it. It doesn't, because it is not returning. So yeah, it gives me 125. Right. So we also saw how what are comments, we saw what are recursion, and we also briefly digressed into how we can control the display, using print function. Now we'll move into storage. So till now, Python. So we saw how computer was used for calculation. We saw how from calculations, computer scientists move into making programs, whose first part was to have a user interface. Then it should be able to compute logic. Then it should be able to do repetitive tasks. Then it should be like higher. We went to higher complexities with function. We went to a higher complexity. Now it can not only compute expressions. It can like compute. Um, you can have like user defined functions. So it is not no more restricted to calculator defined functions. It's now its scope is more broad. Now what computer scientists later also saw, okay, all these are good, but then this machine, the computer, can also be used as a storage environment. Okay, the storage thing started with people storing high and low voltages in magnetic tapes. So high and low voltage means one and zero. It's interpreted as one and zero by the computer. So people saw okay, they can actually store a lot of high and low voltages or through the magnetic tape. And that's how hard disk came. Then people went on to silicon into silicon based storage devices, and that's how SSD came, solid state drive. Right. So people saw okay, we can use this computer as a very effective mode of storage. So storage is there both beyond, both in the program and beyond the program as well. Okay. Python has some very specialized data types for storing stuff. It is sort of a container data type, which can store multiple stuff inside it. So first is list. Anything enclosed with square brackets is called a list. Next, tuple. Anything enclosed in parentheses, round brackets. Then we have dictionary, which is basically a list, right? It's basically a list, but with slightly different indexing. So I hope you remember what are indexing. Nevertheless, it will get briefly recapped in list and tuple. Um, so then let's just move forward with list. Take a list is anything enclosed in square brackets. This is a list. These are some of the examples of list. Okay. You can store anything inside list. It need not be of the same data type. It can be of any data type, and it can be of any length. Right. List can be of any length. Okay. But of course, theoretically it's any length. Practically it's restricted with the amount of RAM you have in your computer. Um, you can actually store expressions, but then if you store them, Python actually computes them and then store them. You can also store a list inside list. Okay, you can store string. You can also store a list inside list. In fact, in later slides, we'll see a very good, curious and interesting application of storing a list inside list. So these are the important ones. Like you can store expressions, you can store lists as well inside lists. Okay, lists also have a indexing. Okay, the 0, 1, 2, 3, 4 is our indices, right? So similar to string, we saw indexing in string. Lists also have an index. For each position, it has an integer value, which like specifies the position. The indexing starts from 0 and it goes till 4. There's one more indexing which actually goes the opposite way, which starts from 1 and it goes till minus 5. It starts from minus 1, goes till minus 5. It starts from here and it goes till here. Okay, the proceeding is in this way, from right to left. But then we'll not really spend time with that form of indexing. We'll spend time with the default mode of indexing. You can, if you're more interested, you can actually explore the negative indexing as well. Okay, it's not very difficult. It's a little time consuming. Um, so the first operation we'll do with the list is how we can traverse a list. Okay, how we can traverse a list. So there are I wrote three different codes. Okay, I wrote three different codes, and all this code actually do the same thing. It traverses the list. By traverse, what I mean is, you should be able to print all the, you know, numbers kept inside the list. Okay. How to traverse a list is you should print one by one all the numbers kept inside the list. Basically, I mean, I say it is printing, but then it's not really restricted to printing. You can like, it's basically what I mean is accessing all the individual elements present inside the list. So the first example is using for loop for I in D. So now this variable I is taking values in D. Earlier, I was taking the values mentioned by that range function. Now it's taking values present inside this list. So as I takes the values inside list, we print I. Okay. So in this way, we can access individual elements present inside the list. There's one more code. This is working in a slightly different way. So we also used a very special function here called len, which gives, and we pass this list inside len. This len gives us the length of this list. That's it. You can pass a string as well inside it. You can pass a tuple, yeah, a dictionary, anything you can pass. It will give you the length of it. Okay. Basically, which means ki how many stuff does it is it carrying. So we define this variable j, and j is taking the values which start from 0 and it goes till length of d. Okay. But it ignores the final value. It goes till length minus 1. Right. So the length here is 1, 2, 3, 4, 5. 5. So length is 5. So index, the values which j will take is starts from 0 and it goes till 5 minus 1, 4. So 0, 1, 2, 0, 1, 2, 3, 4. So it will take value 0, 1, 2, 3, 4, and as the the variable j is taking all these values, we'll also execute this code block which is print d of j. So d of j, if you remember, is like accessing a index. Okay, in string we wrote something similar to access the element present in a particular index. So if you want to access the um, element present at index 2, we write d square bracket 2 square bracket close, and it should give you d double bs. Right. Um, so this is how this code is running. Okay, this is slightly different. Here the variable is taking values directly from the list, while here the variable is taking values of the indices of the list. Okay. Final, we also have an example of while loop. Okay. We have a variable which starts from 0 and we very smartly increment it in each step of the loop. Okay. And as we are incrementing, we are also printing the the corresponding element. The condition here is that I should be less than length. Okay. If it is even equal to length, the loop will terminate. So until I is less than length, which is 5, I will keep, we'll keep printing the element present at I, and I will keep incrementing itself. Right. So all the three codes do the same thing, which is to print this output. Right. Here we just showed how we can display all the elements. We can also access them and you know use it to some sort of computation, right, as a part of our algorithm, as a part of our program. Um, Now, as in the next step, here is a list of all the operations you can do with list. Okay. You can simply display it using print. You can concatenate a list, basically join the list. Okay. Just like string, you can concatenate lists. We can also replicate list. Okay. We can also do a sort of equality check. Now, for equality check, all the positions have to be same. Okay. It's not that the elements have. The element set has to be same. The positions also have to be same. Um, we can do indexing. We just saw how we can do indexing. Okay, we can access an element of a particular index. We can also do slicing. Okay, we can access a sub list of the parent list. Please remember here it accesses the element present at 1, 2, not 3. 3 is ignored. And final thing is we can also edit it. So list also support editing a particular element. So how we edit is basically we first need the list defined, then we write a1. So in this way we access the element present at index 1, and we assign a value 5 to it. So at 1 we had 2, so now we assign a value 5 to it, right? And then we simply print it, right? So this is called list editing. Okay, so container data types which support this sort of editing are called mutable data types. Which don't, they are called immutable data types, right? So this is again some info. Now we have tuple. Tuple is again anything enclosed within parentheses. So these are some of the examples of tuple. You can put, push anything inside two parentheses and it defines a tuple. You can also have lists inside a tuple, right? You can also have a tuple inside a tuple. The indexing is similar to a list and a string, and but the operations as well are similar. Okay, the operations are also similar. A tuple can be concatenated, replicated, indexed, sliced, but it cannot be edited. So it is called an immutable data type. String is another sequenced data type, but then it is not a container data type. It cannot like contain anything. It is like it, a sequence of characters or a sequence of substrings. Okay. Strings are also indexed, and strings are also immutable. Means you cannot like access a particular element and change it. You cannot do that with a string, right? So the next thing is dictionary, right? So dictionary. This is how you define a dictionary. Okay. We saw very quickly. Just go to the indexing, right? So in the previous slides, we saw there was the indices were integers. It started from 0, it's ended at length -1. But what if I want to like have a custom index? Okay, the index has to be user defined. There are many reasons why I might have it. Like let us say I have a set of word and meanings. So there's a word and there's a meaning, just like a dictionary. And I want to somehow store it in Python. How would I store it? The best way is a dictionary. Okay. So the indices would be the words, and the values, okay, the elements would be the meanings. So in the same way, we have the dictionary, okay, the indices. These are the indices which are user defined, okay, no more integers, but then they have to be immutable, okay. um, and these are the elements or the values. So these indices are called keys, okay, in some technical terms, and these elements are called values. Keys have to be immutable. If you want to access the keys, just define a dictionary. So this is how you define the dictionary, right? So you have this curly bracket. So we are utilizing all the brackets present inside in our keyboard. We are utilizing all of them. We utilize this curly bracket, and then you define a key, colon, and the variable. I mean the value. Then a comma to separate. Then again a key, colon, and the value. Comma to separate a key, colon, and value. Right. So dictionary is basically a key value, combination. Now, since these keys actually serve as indices, these keys cannot be duplicated. Okay, there can be no duplications. And since you cannot have an order between these indices, a dictionary is called an unordered list. I mean, an unordered set. Okay. So a dictionary is basically an unordered. I mean, the true definition of a dictionary is an unordered combination of key value pairs, right? Enclosed within, of course, curly brackets. So now we can just go into the previous slides. You can define a dictionary like this. You can also define a dictionary like this as well. These line breaks are conveniently ignored by the Python, executioner. The technical term for Python executioner is called the interpreter. Okay. Interpreter is what is a program which actually executes your Python code. It executes it line by line. This is some slide digression. We'll quickly move forward with our session. If we display this, if you want to display this, we simply put it inside a print, and the output is something like this. Basically, the same dictionary displayed to us. We just saw this. we'll now move to what operations you can perform with a dictionary. So what operations you can perform? You can edit the values. Okay. You can access a value just the way you access in the just the way you have indexing in list, tuple, and string. The same way you have the indexing in dictionary. You can access a value. You can also edit it. So here we have this third comma three. We access it and we edit it to 3 comma 2 comma 1 comma 3. Right. So when we print it, the output would be this. Right. So the third comma 3 is now possessing 3 comma 2 comma 1 comma 3. We can assign new values as well. So if you can assign a new key value pair. You just write a 44. 44 is not present here, right? 44 is not present here anywhere. 44 is not present. We assign it a value, and when we print a, this 44 gets assigned at the end. Although it's unordered, but still it like gets assigned at the end. Right? It's kind of convenient for Python, so it assigns it at the end of the dictionary. So now, yeah, this is how you can traverse a dictionary. So I in a. So I is taking all the values present in the the keys of a. So I takes the value of keys present in a. So I will take. So if I do for I in a, I will take the value 1, second, third, comma 3, 0.4, and 5 by 1, which is basically 5.0. So the variable I will take the key value, the values of the keys. Okay. So I will take the keys. And if you want to print the values as well corresponding to key, but the elements corresponding to key, you have to do AI. So AI is basically again indexing. When we execute this code, okay, when we execute this code, we'll print key, the first key 1, the value corresponding to it 2, then the second key second, the values corresponding to it 2 comma 3, the third key third comma 3, the value corresponding to it is 3 comma 2 comma 1, and so on. So yeah, again, please remember that these keys cannot be mutable data sets. Like it cannot be a dictionary, it cannot be a list as well. While the values can be anything, it can also be a dictionary as well, like we see here. Okay, so we can have a dictionary inside a dictionary. Such a data type is actually called a JSON data type. Okay, a dictionary inside dictionary. It's a very common file storage medium actually. Okay, it's a very common way to not a file exactly a file storage medium. It's a common way. It's a common data type. It's like present everywhere. It's also like compatible with Java. It's also compatible with HTML. It's also compatible. It's definitely compatible with Python as well. Um, so this JSON is I mean uh, kind of not exactly, but from a plan view, it is like sort of a file storage medium only, and it is basically a dictionary inside a dictionary. Now moving on, so we had this a dot values, a dot keys. This dot keys, this appears like a function call, right? This appears like a function call. This is in fact functions. These are special functions. We call them behaviors or methods. Now, Python is an object-oriented programming language. What's object-oriented programming language? It's a slightly advanced concept in programming, which is sort of beyond the scope of this session. I mean, again, I would, if you are interested, there are plenty of resources available in internet to learn. But currently, what we are interested in is um, what are these functions? These functions are behaviors which are associated with the dictionary object. So dictionary is actually an object. So all the data types are actually objects in Python. I mean, not specifically objects, are classes in Python. The values, I mean, all the variables. If you define a variable having a certain data type, it has something called an attribute and behavior. Okay. Attribute are basically again some variables which are associated with these variables. Variables, behaviors. I'm sorry. Behaviors are some functions associated with these variables. So if you do store a dictionary type data in A, so dictionary has this values. values near function as a behavior associated with it. So this values function also get associated with the variable a. And what is the role of this values? This returns a list of all the values. Similarly, this keys return a list of all the keys. ठीक है. I would encourage you to find out such behaviors for other data types as well. We'll very quickly show some behaviors. ठीक है. Like integer. ठीक है. Integer. Floating point. Floating point has a behavior called isInteger. It returns true if this if this is like an integral number. Um, Strings have a behavior named the upper, which basically capitalizes any word, capitalizes any string. List has a behavior called append. So append takes a argument as well. Append takes an argument. Like here we give an argument 3, and basically adds this 3 to this 1 comma 2 list. So the output is 1 comma 2 comma 3. Similarly, tuple has a behavior called count, which basically gives the count of the unique. Okay. mm, so tuple has a called count, which basically gives the number of times this. It takes an argument. It takes an argument. It gives you the number of times this argument appears in the tuple, right? And dictionary is again having a get, which doesn't do anything other than indexing. The same operation is indexing, but yeah. So you can like have a quick look over all these. Okay, we won't like invest a lot of time over this. Like since we are running and we have to cover a lot of topics, we won't invest a lot of time over this. The slides I will share them with you. You can like quickly have a look over them. I would also encourage you to like explore more behaviors associated with all other data types. Okay. Now with this we actually complete the all the paradigms associated with Python programming language, right? So we'll quickly recap what we covered with in storage. We covered list, we covered tuple, we covered dictionary. Uh, Dict is basically the Python, how Python like mentions the dictionary. Okay. So list is a ordered mutable sequence of heterogeneous items. Tuple is ordered immutable sequence of heterogeneous items. Dictionary is an unordered mapping of key-value pairs. Right. Now we move forward to other mediums of storage. Right. So these are the different the default the built-in modes of storage, right? The strengths are they are built-in, they are extremely flexible, and they have really easy syntax. But the limitations, they have really big limitations. Really hard limitations, which is they are very heavy on RAM and CPU. They have poor memory locality, like they manage memory in a different poor way. As a result, like when you have a very large list, it will take a huge RAM. Right. It does not support specialized hardware. Like there are a lot of specialized hardwares available, like which can do your computations in a much quicker way. For an example, GPU. Okay, I hope this is now a buzzword in today's world. The GPU, right? The GPU, it's a very costly hardware, and it's also difficult to obtain as well. So GPU is a very specialized hardware. Python by default does not really support any computation over GPU. What exactly is the purpose of GPU? Like GPU does not generally come integrated with your computer. It's like mostly an external piece of hardware. What's the purpose of GPU? I'll quick highlight in short time. So that's the reason we have these additional tools, which is basically libraries in the form of Python libraries called Numpy and pandas. Now, what are libraries first? Libraries, we saw how we can define functions, right? Now, let us say I like define a lot of functions, and what I do is I don't want to define them again and again in my code. Okay. So what I do is I just make a Python code, and I define all those functions there, save it, and I just use this import keyword. Okay. I don't think I have that in. I'll go to the code. Okay. I use this import keyword, and what this does is this will retrieve all the function definitions present in that file into my current code. Okay. So this pandas is a huge file. Okay. This is in fact not a single file. This is a huge set of files with a lot of function and object definitions as well. Okay. I cannot like afford to have all those definitions in my code here right now. So what I do is I conveniently use the import keyword. I import the module name. Okay, this is the name of that set of files, and I associate an additional identifier to it. I imported pandas as PD. I import numpy as np. Now, how you can actually install these libraries? These do not come by default. You install it using pip install pandas and pip install numpy. Right. You can do a slight googling if you face any challenges, or you can ask any doubt to me. Um, yeah. So pip install. Please do remember to write the exclamation mark here. Okay. Next, you just have to execute it. By default, it is there in Collab. So if you're doing the programming in Collab, by default it is there. So you don't have to install it. But in case you're like doing it in your own system, it might not have this pre-installed. So you have to write this pip install pandas. This is only valid for this Jupyter type environment. If if you're using something else, you just open your terminal, right? And there you write this pip install pandas. Now for this you need Python installed in your system, and you have to install it such that you have this pip in something called in your environment variable, right? So what I would recommend is when you're installing Python, you go for the custom installation and tick every checkbox is there, right? As a rule of thumb, tick every checkbox is there. It will take some space in your system, but that space is not very large given the you know given the interface. That space is not very large, hardly 200 300 MB it will take, MB not GB. So we use the import keyword to import these libraries. So these are additional libraries with some additional data type definitions and some additional functions. Why NumPy and Pandas? These are very good at performance. These are backed by C. C is the mother of all programming language. It's a very low level programming language and it's really fast. It was the first popular programming language. It was developed, I think, in 1970s. C is really fast and it's very optimal as well. Like it is not heavy on memory and CPU. It has contiguous arrays, which means like so. This is like a data type reserved for C only. Arrays are data types using C. Okay, it's a way to get those data types in Python. Okay, it's good in speed. It's low in memory. By memory, I mean it will consume less RAM. It supports vectorized operations. Now, what vectorized operations mean? I'll show it in next slides. For now, you can like think of it as all those vector operations you have in maths, like dot product, cross product, multiplication, scalar multiplication, the matrix operations as well. They also come under vectorized operations only. Matrix multiplication, addition, subtraction, scalar multiplication, and stuff. It has a very rich tabular API, right? It supports a lot of features like so SQL is so before all this pandas, NumPy, Python, SQL was the industry standard, right? Uh, so SQL was the industry standard for using data sets. So when you have like a table, right? So when you have a table for being able to write some code and manipulating a table, we use SQL, right? The SQL provide a lot of features. Okay, we'll see what these features mean. Okay, so this the pandas supports all these features. You have some advanced indexing. Okay, we saw some advanced indexing in dictionary, but you have similar advanced type indexing in pandas, and you know it's much faster and has a lesser memory overhead as well. Alignment, missing data handling. These are other stuff you'll understand in time. Ecosystem fit, right? So this NumPy, Pandas, SciPy, scikit-learn, Matplotlib, all these libraries combine to form a very good data science ecosystem. They are all they are all like interdependent, and they're, I mean, not always interdependent, but then they are like complementary, I would say, not interdependent. I would say they are complementary. They complement each other's capabilities. Some of them are interdependent, like at least all these are dependent over NumPy and Pandas. Okay, but these are independent from each other. But these depend on NumPy and Pandas. So together, NumPy, Pandas, SciPy, scikit-learn, and Matplotlib, all these libraries form a very solid, very robust, and complementary set of libraries used by data scientists across the world. Um, Now we will quickly go through the session roadmap. This session is about NumPy arrays and pandas. Okay, we'll start with NumPy arrays. We'll see how you can create NumPy arrays, how you can manipulate them, edit them, aggregate them, and operate them. Okay. Then we'll move into pandas. We'll see how we can do input and output. Okay. How we can access them, how we can traverse them, how we can transform them, and how we can combine them. Right. So we'll quickly move into NumPy. Okay. So ND array is the new data type introduced in NumPy. Okay. So this is the NumPy's core object. This is a homogeneous. Unlike list and tuple, this is not heterogeneous. This has to have a single data type. A homogeneous n-dimensional array. Array is basically, you can, for the time being, you can think of a list which has a single data type. Right. So if it is integer, it's all integers. If it is decimal or floating point, it has to be all floats. Right. So it's a homogeneous n-dimensional array. All elements share one data. It has a fixed size and a contiguous memory. Okay. Now it has a fixed size, but then that does not really restrict you from extending its size. But then that's not very optimized. You can extend its size, but then that comes in Python speed. Um, so by default, it has a fixed size. Okay. Similarly, it shares only one data type, but then there are actually ways to you know store multiple data types inside a ND array, but then again, that is not very optimized. Okay, it supports vectorized operations and broadcasting, so it does not depend on Python loops. Instead of Python loops, it actually uses all those vectorized operations which are defined in vector algebra and matrix algebra. I hope you are like familiar with these terms: vector algebra, like dot product, cross product, वेक्टर वेक्टर का नॉर्म स्क्वायर रूट करके स्क्वायर करके ऐड करना वगैरह. It has it defines the foundation for all advanced data science libraries. So what exactly, let me tell you what exactly I mean by vectorized operations. So there's a very specialized hardware called GPU. The primary role of GPU is graphics processing. Now graphics in computer is all about matrices. Okay. So GPU is actually optimized to do matrix level operations. It can do very matrix multiplications, matrix additions, matrix subtractions, scalar multiplication in really fast. It is I mean in a really fast speed. At a really fast speed, it can do that. Um, you know the GPU, the speed of GPU in matrix multiplication is 5 to 50 times faster than the CPU. Okay, depending upon what CPU you have, but then GPU is like 5 to 50 times faster than CPU in doing matrix algebra, matrix level operation, matrix level calculations. So GPU is it is primarily it was designed for processing graphics, in for for developing game and playing game, for graphics rendering, like making all those computer generated imagery. But then in 2000s, curious scientist came with the name called Andrew Ng. Okay, this scientist actually showed कि okay, we can use this GPU for doing data science as well. How? By using this library NumPy. I mean, this NumPy was not existing then, but then he like made this ND array, which actually uses this GPU to do all the matrix multiplications. Okay. I mean, we also in data science we also deal with matrix, but then how we actually define a matrix in Python, we'll see um, in the coming lectures. I mean, in the coming slides. So we first deal with how we can create a ND array. So we created, we first have to import NumPy. We import it with the identifier NP. Okay, we write np.array and parentheses inside we just put a list. All the elements of the list have to be of the same data and data type. If they are not, then we'll see what happens then. Okay, later. But then currently, just remember all the data types have to be of this. I mean, all the elements have to be of the same data type. Then we we can also, so what this does is this function, this is a special function, this is called a constructor. Okay, this returns a this returns the what we call an object, which is basically the ND array. Okay, you can store that object in a variable. Okay, you can also do operations which we'll see in short interval. This is one more way to make ND arrays. So this makes a ND array, okay, of size 4, okay, which contains only 1. This makes a ND array of size 6, which contains only zeros. This makes a ND array of size shape, and the fill value is, I mean, it has only this fill value. So let us say I call np.full. In fact, we have some examples. Let's go into the example only, and there you'll get some clarity. But then before that, we'll see what this that NP arrays are generally meant for numeric calculations. So we generally don't store lists inside it. Okay, we can store a single character, but we generally don't store list inside. I mean, we generally don't store these container or sequence type data types like strings or lists or dictionary or tuple or anything. Okay, and NumPy arrays only have one data type, but then that's like manipulatable. So here are some operations. I mean, here are some ways of creations. We print it, okay, and this is what it outputs. It looks like a list, but it is not exactly a list. It's not a list. It just it just shows like list, but it is not a list. It just shows that the ND array consists of 1, 2, 3, 4. The ND array is a programming analog of the vector in maths. So a vector like this basically means 1, 2, 3, 4 as a vector. We in 12th standard we saw three-dimensional vectors like 1 I cap, 2 I cap, 2 j cap, 3 k cap, right? We can have n-dimensional vectors, right? And in the classical vector algebra or um, yeah, so in the classical vector algebra, the vector is actually defined as a column matrix. Okay. So like that is some slight digression in the mathematics behind, but this is this is a vector. Okay. This is a vector of dimension 4, a four-dimensional vector. This print once, this creates a vector of size 4 only with ones, zeros, zero vector of size, sorry, for the typo, this has to have 6. This np.full we saw in the previous slide. This creates a vector of size 4, which consists only 3.2. So 3.2, 3.2, 3.2, 3.2. This linspace, this is a curious way of constructing. Yeah, so this linspace, this is a curious way of constructing. This constructs a vector of size which starts from 0, ends at 10, and is of size 3. Okay. Now it gives me this result. So 0, 5, and 10. Okay, 0, 5, and 10. But then it could have also given me like 0, 6, and 10, or 0, 3, and 10. What stopped it from? So what stopped it from is that this linear constraint. So the increment would be linear in nature, so equal difference. Okay. So if I had specified 0, 10, and maybe like 4, it would have given me some, some decimal. It would have given me four numbers, all of them decimals. But then the difference between each number has to be same. That's what linearity constraint means. Going into the creation stage, right? Further ways to some additional concepts in creation. So we saw we could have a list inside a list. Okay, we could have a list inside a list. We already saw that. If we print it, we can. This also has the indexing. If we print, it shows 1, 2, 3. This also supports further indexing. Like if you think like logically, A0 is basically what 1, 2, 3. 1, 2, 3 को अभी फिर से अगर इंडेक्स करना है तो क्या और एक इंडेक्स डाल दो. This gives 2. ठीक है. Similarly we can also do 2. So 2 is this 3, 2 वाला. उसमें 1 मतलब ये 2. ये 2 ये आउटपुट देगा. ठीक है. So two-dimensional lists are a logical extension of the classical lists. ठीक है. There can be further extensions into three-dimensional or even n-dimensional list. मतलब लिस्ट के अंदर लिस्ट के अंदर लिस्ट के अंदर कितना भी लिस्ट बना दो. ठीक है. Now two-dimensional list can have multiple lists of multiple length. ठीक है. But we can keep the inner list of same length. ठीक है. And that is what programmers use to represent a matrix. So a two-dimensional list of common length is called a matrix. Now this is not very optimized, so we optimize it in Numpy. Okay. So Numpy uses this concept to make a special data type called matrix. Okay. It also have two-dimensional vectors as well. So matrix can be operated just like matrices. Matrices are merely two-dimensional arrays. So NumPy has two data types. So it uses this two-dimensional list into two data types. It can make a matrix of it. It can make a two-dimensional array as well of it. Okay. So matrix is a two-dimensional array with some added functionality of matrix multiplication. NumPy arrays support both multidimensional arrays as well as matrices. How you can make a multidimensional array? This a np.I. This gives you a identity matrix. Okay. Let's see how it gets executed. We'll quickly just do this np.I3 and we execute it. Let's just print it as well. Print. So this is what I get. Okay, this now looks like an identity matrix, isn't it? This looks like an identity matrix, but then this is a two-dimensional array. Okay, this is a two-dimensional array. Now, if I want to convert it into a matrix, I can do np.matrix, and now this is again the output is same, but then this is now a different data type. It is a matrix data type now. Okay, so this np.ey3 gives me an identity matrix. If I wrap this around a matrix, this gives me a this identity matrix, but this is a NumPy array. Now, if I wrap this variable across this np.matrix, this gives me a NumPy matrix. This is another way we can create a two-dimensional NumPy array by giving in a two-dimensional list. Okay, and again, this is how we can convert it into a matrix as well. So here are some ways of creating two-dimensional arrays. Okay, we shall not really concern a lot with matrices for the time being. Our primary concern is ND arrays only. Our primary concern for the time being shall be ND arrays. So we'll see how we can, the different ways of creating ND arrays. Okay. So here we saw कि so 4, 2 बाहर का list is so बाहर का array is of length 4, अंदर का array is of length 2. Right, 4, 2, 0, 0 np.0 np.full 3, 2 बाहर का array is 3, अंदर का array is 2. Right, so this is what I was telling as well. Length of outer list, I would change it to length of outer array and length of inner array. Let me do the positioning. Yeah, fellows, I see some doubts about where they can get the notes. I'll share all these all the PPT to you, guys. I'll also share the Jupyter notebook I have made so that you can like run the code, revise it, learn it as well. But then let's focus over this. We have around 5 minutes remaining. I'll quickly cover this NumPy stuff. Okay. So we saw how we can create NumPy arrays. Now we'll see how we can access the different attributes. So I said कि this gives an object. So object has some attributes associated with it. Like so this is these are all the attributes. Okay. So if I define a array like this, array equals to numpy, I mean a double r equals to numpy dot array. This is a two-dimensional array. If I write this r dot endim and put this inside a print, this will give you the number of dimensions, which here is two. A double r dot shape. This will give me the shape. Okay. Now shape is basically a tuple. First, it will have the outer dimension. Outer dimension here is क्या? बाहर वाला list has only two things, right? So bahar wala, it will the first element would be 2, right? The first element, so this will give me a tuple. The first element would be 2. The next element is अंदर वाले list का dimension क्या? ठीक है. अंदर वाले list का dimension is 3. So this will give me 3. Now here a good doubt can come कि okay, what if I have a list with so यहाँ हमने दो list बनाई, ठीक है? और दोनों list का length 3 ही रखा है. What if I had like three? What if I ये 3 है, इसका लेंथ 5 हो जाता तो 5 हो जाता तो वो मतलब स्टैंडर्ड नंपाई एरे नहीं रहता है, फिर वो कुछ और बनने लग जाता है, ठीक है? या तो हो सकता है वहां पे एरर दे दे या फिर एक अलग सा डेटा टाइप रखे. बट देन स्टैंडर्ड नंपाई एरेज हैव टू हैव द इनर लिस्ट ऑफ सेम डिमेंशन, ठीक है? द टोटल नंबर ऑफ एलिमेंट्स, ठीक है, एरे डॉट साइज करोगे तो दैट विल गिव यू द टोटल नंबर ऑफ एलिमेंट्स व्हिच हियर इज 6. Array dot d type करोगे तो this will give you the data type of all the elements. Now here all the elements are integers, so it will give you int. मतलब it will give it in a slightly different way, int. If one of them was even a float like this, ये 5.0 अगर होता तो ये int की जगह float दे देता, कुछ तो float देता like np dot float वैसे कुछ देता. Array dot item size, this is bytes per element, ठीक है? Okay, I'm sorry. Yeah, this is bytes per element. So bytes per like 6 elements, right? And this is integer. Integer is about 4 bytes. 4 bytes yani a binary sequence of length 4 into 8, which is 32. 32 length का binary sequence. ठीक है? So bytes per so each integer is actually a 32 sequence 32 length binary sequence. So we have about 6 such integers. So we have 6 times 32, which is 192. 192 sequence by binary number. So this would be a like 192 length binary sequence, this entire array. So the memory footprint would be 192 bits. Or if we divide it by 8, that should be around 24 bytes. Okay. We can have millions of bytes memory footprint. Okay, that doesn't like really. So what this would, but then what this would output is r dot item size would give you, I think, 4 bytes per element. It will give you 4. Okay. The total memory footprint, how will you get is r dot size times r dot item size. Okay, this would give you the total memory footprint in bytes. Next, we go some additional operations. You can do slicing just the way you had in list, but then this has some additional functionality of multi-dimensional slicing. Okay. Now, array 1, 2 gives you बाहर वाले लिस्ट का पहला इंडेक्स, आई मीन बाहर वाले लिस्ट का इंडेक्स 1 का एलिमेंट एंड अंदर वाले लिस्ट का इंडेक्स 2 का एलिमेंट. सो दिस विल I'll show an example of it. Let me define my array as right. and I'll do print array 1 comma 2. So what this gives me is the outer list index 1, which is this, and from that the inner list index 2, which is this 6. So this is 0, this is 1, this is 2. So it is basically analogous to printing array 1, 2. So this is analogous to it. We can also have like multi-dimensional slicing as well, right? So this, if I do, so this will do. So what this means is कि बाहर वाले लिस्ट का सारा चाहिए. So सारा चाहिए मतलब क्या कि हमने स्टार्ट और एंड कुछ हमने लिखा नहीं है, ठीक है. स्टार्ट और एंड लिखा नहीं मतलब पूरा पूरा लिस्ट चाहिए. बट अंदर वाले का सिर्फ वन चाहिए. तो मतलब व्हाट इट विल डू इज कि अंदर वाले का सिर्फ वन को स्टोर करेगा और बाहर वाले सारे दे देगा. सो इफ आई जस्ट प्रिंट इट, दिस गिव्स मी 2 and 5. Right, so this gives me 2 and 5. So this is sort of interesting, right? Now we can try this as well. Let's try this as well, but this is not this won't be valid for this array because this does not have that many numbers. I'll just do right. So if I do this, what this gives me is कि बाहर वाले लिस्ट के सारे चाहिए बट अंदर वाले का 0 और 1 चाहिए, मतलब 1 और 2 और 4 और 5, 1 और 2 और 4 और 5, बट बाहर के दोनों चाहिए. ठीक है. Now if I like add some more stuff to it, now you can like very nicely see कि what it is doing. बाहर वाले सारे चाहिए, ठीक है. दिस मीन्स बाहर वाले सारे चाहिए और अंदर वाले 0 और 2 चाहिए, मतलब दिस 0 से लेके 2, 2 एक्सक्लूडेड. सो 0 और 1 चाहिए, तो 0 1 0 1 0 1. So this is what I get as input output. So right, so I'll stop with this slide only. Okay. um so advanced assignments, so you can actually like you can access sub arrays used by this slicing. You can also edit this edit the array by accessing sub arrays. Like I use this, and what I do is I define an array one instead of I'll 0 comma 0, or maybe I'll just define it like this. np dot zeros, and it would be 3 comma 2, right? So this is how I define a so np dot zeros 3 comma 2 will define me a nd array of dimension 3 comma 2. So bahar ka list 3, andar ka list 2. And if I just do this assignment and then I print the array, you realize all these elements have been converted to zeros. Okay. Right, so this is again very interesting, right? So you now realize how better this nd array is in comparison to the list. Okay. You have advanced slicing, you have advanced assignments as well. Okay. You have some fancy indexing as well. Okay. So let us do something like this कि बाहर में मुझे चाहिए सिर्फ 0 और 2 चाहिए, और अंदर मुझे चाहिए सिर्फ अंदर भी मुझे वही चाहिए, अंदर भी मुझे 0 और 2 ही चाहिए. ठीक है. So we printed the array previously. So this was the array. Yeah. So here what it shows is कि बाहर मुझे 0 और 2 चाहिए. Okay, I'll write it in a different way. Right. बाहर मुझे 0 और 2 चाहिए, अंदर भी मुझे 0 और 2 चाहिए. Now this got a little messed up. So 0 और 1 मतलब this it will give and this it will give. ठीक है. If I had done 0 and 2, then it would have given me this and this. ठीक है. एंड अंदर मुझे सिर्फ 0 और 2 चाहिए. तो अंदर मुझे सिर्फ लाइक zeroth index and second index चाहिए. So what it actually, now it hasn't been able to do this very correctly. Yep. Oops. Sorry for that. So it has it now it will be more clear. Now it will be more clear. So bahar it gives me 0, 1, 2, 0 and 1, and so it gives you this list, it gives you this list, and inside it gives you this value, sorry, this value and this value, right? So 0 0 diya or 3 6 diya, right? So this is how you can actually play around with the indexing. So this is how like advanced the indexing is with NDRS. So it has fancy indexing. It has also got logical indexing as well. So I will print the um, parts which are greater than 4. Only 6 is greater than 4, right? So only 6 is greater than 4. So it gives you me only 6. Okay. So this is like again some advanced form of indexing. Okay, you can play around with this. I'll give this notebook to you guys. You can like play around with the notebook. So yeah, with this now I realize that I've already passed the allotted time. So I would like to end this session here. Okay. In the next session, we'll see how we can like play around with and how we can like play around with the new. We'll also see a new library called pandas and how we can play around with it. Okay. The slides I'll share with you so that you can revise and learn. The notebook as well I'll share with you. I'll also share an assignment with you guys. Okay. I hope the previous assignment was interesting and you could learn something out of it. The current assignment would be like the today's assignment would be even more. I'll try to make it as interesting as possible, right? My request would be you can use chat gpt or internet to learn, but don't use it as your replacement. Don't make your virtual images here. Okay. Output your genuine responses. Okay. Let's not try to make your own virtual response. Let's not try to make our own virtual images at the learning stage. Do this later. Later, right? So this is how you can like play around with this.
You can leave the session, but please remember to mark your attendance. I hope you can hear to me. My You just shut down. Please mark your attendance. Remember to mark your attendance. And with that, I will close the session. Thank you for being there. Good night, and I'll upload all this stuff to you. Thank you.